The anabolic window has been shown to largely be a fitness myth. But what if I told you that it may very well exist, but not in the way we think it does? Well, in this video, we'll uncover just that. When we think about the anabolic window, we usually imagine something like bros chugging their protein shakes in the parking lot immediately after their workouts. I've even seen some advanced techniques in the locker room where bros inject some sort of liquid protein right into their veins. Man, I've still got so much to learn about fitness. But what researchers realized is that this anabolic window doesn't really exist, and timing your protein is pretty much pointless. Instead, the consensus is that simply getting enough protein throughout the day is all you need to get the best gains. But if that is the case, what the heck then do I mean that an anabolic window might still exist? Well, what if protein was actually the wrong macronutrient to focus on? If a new study is anything to go by, then maybe we should have been focusing on carbohydrates instead. More specifically, this study seems to suggest that there is a potential anabolic window for the synthesis of the macromolecule known as glycogen, the stored form of energy we get from consuming carbs. Let's take a closer look. In this study, subjects performed 2 high-intensity interval training bouts separated by 24 hours. In the first bout, they performed 10 sets of 2-minute high-intensity cycling intervals with 1 minute of rest between them. The second bout was the same, except they performed as many intervals they could until they reached failure. The goal of the study was to see how one change to their carb intake affected the measured outcomes. More specifically, immediately after the first exercise bout, the subjects were randomly given one of 2 similarly tasting drinks, one containing carbs and the other containing no carbs. After 3 hours post-exercise, all subjects were then given a lunch that included carbs. They were also given matching food and drinks throughout the course of the trial to keep their diets identical, and all subjects participated in both interventions using a crossover study design. Now, let's talk about the results. Multiple outcomes were measured, and outcomes on molecular responses were essentially the same. But there was a tiny difference in whole muscle glycogen levels before the start of the second exercise. More on this later. For us, perhaps the most relevant findings were related to the second exercise trial where subjects performed intervals all the way to failure. When carb intake was delayed by 3 hours, or when the subjects were given the zero-carb drink after the first trial, they reached failure after 12.7 intervals on average for the second trial. But when given carbs immediately after, they reached failure after 18 intervals. In other words, by delaying carb intake for 3 hours, exercise capacity reduced by about a whopping 30%. Naturally, the subjects also reported higher ratings of perceived exertion during the second trial. Needless to say, these results might have huge implications for our exercise goals in terms of timing our carb intake. The big question, though, is why did this happen? Well, we can't actually tell when looking at this study on the surface, but let's go back to that point about glycogen levels. The reported difference in whole muscle glycogen before the second exercise trial was about 46 millimoles per kilogram lower in the delayed carb group. Statistically, this is considered not significant, but maybe it means more than we think. Thing is, glycogen is actually distributed to different subcellular locations in our muscles. One of these in particular is intramyofibrillar glycogen, which is known to power the release of calcium that activates the protein sites of muscle contraction. This region is also known to deplete faster than other regions during both endurance and high-intensity activities, including lifting weights. And even more, other studies have shown it to be particularly sensitive to carbohydrate intake immediately after exercise. Unfortunately, when we used mixed muscle samples to measure whole muscle glycogen, which this new paper did, we can't detect changes in these specific glycogen regions. But what if this small, non-significant drop in glycogen observed in the delayed carb group is disproportionately intramyofibrillar glycogen? That would then explain the dip in performance, and ultimately, it would suggest that an anabolic glycogen window might very well exist. Now that said, let's not run out and spread the gospel of carbohydrate timing just yet, just to end up like protein timing. However, this study study does avoid a major issue we saw with early protein timing research, and that is not properly matching the diets of the subjects. Still, for now, it's best that we just keep this in the back of our minds and not make any big changes to our diet solely to take advantage of this hypothetical window. Some more research would be nice, especially covering more exercise-related mechanisms and different types of exercises, especially lifting weights. However, like lifting weights, interval training does utilize a lot of type 2 muscle fibers, which has also shown to deplete intramyofibrillar glycogen quite quickly, so there is a bit of carryover from this study. But hey, if shifting some carbs around isn't much of a problem for you, then sure, maybe an injection or two of carbs after your workout might not be a bad idea if you want to try to get ahead of the meta. That said, if carb timing ends up being a myth in the future, then you never heard it from me. If you enjoyed this video, then please give it a timely thumbs up and share it with your glycogen-loving friends. Subscribe for more and let me know what you think in the comments. As always, thank you for watching and don't forget to get your protein.